So for today's video, we will discuss the Thevenin's theorem, also known as equivalent circuit theorem. This was created by Charles Léon Thevenin, a French telegraph engineer who extended Ohm's law to the analysis complex electrical circuits. So first, we define first what is Thevenin's theorem. It states that a linear two-terminal circuits can be replaced by an equivalent circuit consisting of a voltage source VTH in series with a resistor RTH, where VTH is the open circuit voltage at the terminals and RTH is the input or equivalent resistance at the terminals when independent sources are turned off. So the formula of getting the current load and voltage load after we get the value of VTH and RTH are IL is equals to VTH over RTH plus RL, or IL is equals to RL over RTH plus RL times VTH. Tapos sa VL naman is we are using Ohm's law. VL is equals to IL times RL. We have three steps in solving Thevenin's theorem. First step is to find the Thevenin or equivalent resistance RTH across the terminals by turning off all the independent source, short the voltage, open the current. Step 2 is find the Thevenin or open circuit voltage VTH across the terminals by using any circuit analysis techniques you like. It's either nodal, Norton's, or mesh. Step 3 is connect RTH in series with the given load across VTH and apply the formula to solve for the current or voltage of the source. So, here are the examples of Thevenin theorem. Find the Thevenin equivalent circuit of the circuit shown below. To the left, find current through the loads RL is equals to 5 ohms, 12 ohms, and 20 ohms. So, dito sa problem natin is given yung voltage of 40 volts and may mga mga resistors, 5 ohms, 20 ohms, 4 ohms, at may current tayo dito na 2 ampere. So, dito sa given na to, ito yung terminal circuit niya. Yan. Ito yung terminal circuit at ito namang natira is ang load niya. So, ito yung load. Yung kung saan yung RL. So, paano nga ba natin i-apply yung mga steps dito? So, sabi nga sa step 1, off all the independent sources. Tapos daw, ang voltage ay i-short. Tapos, ang current ay i-open. So, ganito yung mangyayari. Ganyan. Sabi dito ay i-short daw yung voltage. Tapos i-open yung current. Tapos kopyahin na lang yun. Dito. Tapos kopyahin to. Then dito. Ito yung 5 ohms. Ito yung 20 ohms. Ito yung 4 ohms. So, ito yung ating A and B. So, bakit ganyan na lang? Tinanggal po natin yung RL para mahanap natin ang equivalent resistance. So, ang RH and then para makompute natin ito, since dito po, since ang 5 ohms at 20 ohms is in parallel, so ganito po siya. RTH is equals to, itong 5 ohms at 20 ohms is in parallel sa 4 ohms. So, 4 ohms plus, in parallel siya, so, ganito siya. 5 times 20 ohms over 5 ohms plus 20 ohms. Kasi in parallel siya. So, parang ganito siya. RTH is equals to 4 ohms in parallel to 5 ohms and 20. So, ganyan po siya. So, kapag kinalculate mo yan, ang lalabas ay ang RTH mo is 8 ohms. So, magagamit natin yan mamaya sa pag-compute. So, since tapos ng ating step 1, dumako naman tayo sa step 2. So, sabi niya sa step 2 is, find open circuit voltage across the terminal A and B. Hanapin mo daw ang voltage, yung VTH. So, dito sa given, ganito magiging kalabasan. So, kopyahin mo lang yan. Plus, minus. Then, ganyan. Tapos, dito pa rin yung ampere niya. Na 2 ampere. Kasi ito yung 20 ohms. So, yun yung 5 ohms and 40 volts. So, ganyan. So, ito yung 4 volts. Ito yung A, ito yung B. So, ito yung 4 ohms. So, bakit na naman natanggal yung R load? Tinanggal natin ito kasi dito maglalagi ang VTH. Okay? So, kung napapansin nyo ito, 4 ohms. Nakalutang na siya. Walang dumadaloy na current. Kasi open na siya. Na-open na siya dito. Walang dumadaloy na current and voltage. So, itong 4 ohms ay magiging equals to 0 na lang siya. Okay? So, kung 0 na lang siya, magiging ganito na yung drawing mo, yung figure mo. Kopyahin yan. Kopyahin ulit. Volts. So, ito yung 5 ohms. Ito yung 20 ohms. Tapos, ito yung 2 ampere. So dito, since 0 naman na yung 4, magiging wire na lang siya. So, ito yung A, ito yung B. So, ganyan na lang siya. So, ito yung VTH natin. Okay? So, bakit nga ba open circuit yung tawag dyan? Kasi po, is tinatanggal natin yung R load para makuha natin ang VTH. So, using, sabi sa step 2, gumamit tayo ng mga techniques para makuha yung VTH natin. So, ngayon, gagamit tayo ng nodal analysis. Because, one node lang siya. Isang node lang po siya. So, kunwari, before that, since ang VTH natin is across siya sa 2 ampere at 20 ampere, no. across siya sa 2 ampere at 20 ohms. Nakaparallel siya sa kanya. So, ang VTH na, so parang ganito siya. Itong dumadaloy dito, VTH to, VTH rin to, yun yung VTH kasi nakaparallel naman siya. So, kapag yan, gawa na lang tayo ng do we call this? So, dito siya. Node. Dito din siya. Ganyan po siya. So, ang sa nodal naman kasi, nodal is a summation of current is equals to 0. So, leaving is equals to entering. Okay? So, i-substitute na lang natin to. Leaving is equals to entering at node VTH. So, i-substitute na lang natin siya. Oh my god. Sorry. VTH minus 40 volts over 5 ohms plus VTH over 20 ohms is equals to 2 ampere. So, ito yung leaving kasi nag-leaving siya. Leaving. Tapos yung 2 ampere, since pa ganun siya, so, entering siya. So, ang magiging sagot dito kapag ni-shift solve natin siya is magiging equals to 40 volts. Okay? Ito yung 40 volts natin. So, how can we solve the current? So, since nahanap na natin ang VTH natin, is equals to 40 volts, na 40 volts, pwede na nating makuha at gamitin yung formula kanina para makuha yung I-load at saka voltage load. So, pwede na nating makuha yung I-load sa given na RL kanina. Yung RL na RL is equals to 5 ohms, 12 ohms, saka 20 ohms. Since nakuha na natin ating RTH na 8 ohms, na 40 volts, pwede na nating makuha yung sa problem na current through the loads (12 ohms and 20 ohms. So, from this figure to this. Okay? So, yan. So, A natin. Ito yung B. So, ito yung RL natin. Ito natin na and 20 ohms. So, dito naman, ito yung ating RTH na 8 ohms. Dito naman ay ang ating VTH na 3 volts. So, pwede na nating makuha yung umpisahan muna natin dito sa 5. RL na 5. TH over RTH plus. So, is equals to, ay yung VTH natin, 40 volts over, ang RTH natin is 8 ohms plus ang ating RL na 5. So, it's 3.077 ampere. Tapos, ito namang 12 ang na RL ang hahanapin natin. So, IL is to VTH over is equals to plus ang ating 12 ohms equals to 2 ampere. So, ang hahanapin naman natin ngayon is yung sa RL na 20 ohms. So, IL is equals to, yung VTH natin is 40 volts over yung RTH natin na 8 ohms plus yung 20 ohms na RL natin is equals to 1.429 ampere. So, ang RL na may 5 ohms is 3.077 ampere. Ito naman, sa RL is equals to 12 ohms ay may 2 ampere tayo. Dito naman sa 20 ohms, may 1.429 amperes tayo.